Look up. At the night sky. What do you see? Maybe just a handful of stars, perhaps a planet or two. And of course, the familiar glow of our moon. But honestly, that's just the beginning. That's just our cosmic front yard. Beyond what our eyes can perceive, there's a universe teeming with worlds so strange. For every star you see, there could be a planet, or two, or heck, even 10. We are living in a golden age of discovery, where our telescopes have become powerful enough to peer into the deep dark and actually find these distant neighbors. We call them exoplanets, and they are rewriting everything we thought we knew about what a planet can be. The universe isn't just vast, it's wonderfully, beautifully weird. Let's begin our journey into the unknown and see what wonders await us in the great cosmic darkness. Our first stop is about 63 light-years away in the constellation Vulpecula. From a distance, the planet HD 189733b might look deceptively familiar. It's a gorgeous, deep azure blue reminiscent of our own Earth. You might think you're looking at a tranquil ocean world, a pale blue dot. But you would be devastatingly wrong. This planet's beauty is a deadly illusion. Its stunning color doesn't come from water, but from an atmosphere laced with silicate particles, the very building blocks of glass. This is a world where beauty and brutality are one and the same. The weather on HD 189733b is unlike anything you could experience. This is a hot Jupiter, a gas giant, orbiting incredibly close to its star, completing a full year in just a little over 2 Earth days. This proximity cooks its atmosphere to a searing 1,000 degrees Celsius, about 1,800 degrees Fahrenheit. At these temperatures, the silicate particles in the clouds don't just float, they condense into molten glass. This planet has clouds of glass, and from those clouds it rains. It rains molten glass. But the horror doesn't stop there. The wind on this world is absolutely ferocious. Winds on HD 189733b have been clocked at over 5,400 miles per hour, 8,700 kilometers per hour. Next, we venture to 2 worlds that represent cosmic extremes of creation and destruction. First, let's visit WASP-12b, a planet that is dying a spectacular death. Located about 1,400 light-years from us, this planet is another hot Jupiter, but it orbits its star so closely that it's being torn apart. The star's immense gravity has distorted the planet into a bizarre egg shape, stretching it towards its impending doom. Its surface is roasted to an incredible 2,200 degrees Celsius, making it one of the hottest exoplanets ever found. It glows with a dull, cherry-red heat, a world literally burning up. The tragic story of WASP-12b is one of cosmic consumption. The star's gravitational pull is so powerful that it's actively siphoning off the planet's atmosphere at a staggering rate. A river of gas, a cosmic umbilical cord of death, flows from the planet directly into the star. We are, honestly, witnessing this world being eaten alive. Scientists estimate that about 189 quadrillion tons of its mass are stripped away every single year. At this rate, the entire planet will be completely consumed by its parent star in about 10 million years, a mere blink of an eye in cosmic time. WASP-12b is a ghost in the making, a doomed world giving us a front-row seat to planetary destruction. From this scene of cosmic horror, we travel to a world of unimaginable treasure. 55 Cancri. This planet, just 40 light-years away, is a super-Earth, about twice the size of our planet, but 8 times more massive. What makes it so extraordinary is its composition. Based on its density and the chemistry of its star, scientists believe this world is carbon-rich. And under the immense pressure and heat found deep within this planet, that carbon would be squeezed into its most stable, most glamorous form, diamond. This isn't just a planet with some diamonds. This is a planet that could be made of diamond. Imagine a world where mountains are carved from diamond and canyons glitter with graphite. The surface might sparkle with a brilliance that would outshine any jewel on Earth. Below its crust could lie a thick layer of solid diamond, possibly miles and miles deep. While the surface is likely way too hot for us to ever visit, with temperatures reaching over 2,000 degrees Celsius. Now we journey to a place of profound and unsettling darkness. Welcome to TAR-ES-2b, also known as the dark planet. Located 750 light-years away, this exoplanet holds the title for the darkest world we have ever discovered. How dark is it? Well, it reflects less than 1% of the starlight that hits it. To put that in perspective, fresh black asphalt reflects about 10% of light, and even a lump of coal reflects around 4%. This planet is literally darker than coal. It's a phantom world, a ball of gas so black that it seems to swallow light itself, making it almost invisible against the backdrop of space. The reason for its extreme darkness remains a bit of a mystery, which only adds to its mystique. Scientists speculate that its atmosphere might be filled with light-absorbing chemicals like vaporized sodium or potassium, or perhaps exotic titanium oxide compounds that we just don't see in our own solar system. Like WASP-12b, it's a hot Jupiter, orbiting very close to its star. This means it's heated to a temperature of over 980 degrees Celsius, or about 1,800 degrees Fahrenheit. Because of this intense heat, the planet doesn't reflect light, but it does emit a faint, ghostly red glow, much like the embers of a dying fire or a hot coil on an electric stove. TRES-2b is a cosmic enigma, a dark jewel that reminds us that some of the universe's greatest secrets are hidden not in bright nebulae, but in the deepest, most absolute shadows we can find. Our final destination is perhaps the most paradoxical of them all. Let's travel to Gliese 436b, a Neptune-sized planet about 33 light-years away. This world presents us with a mind-bending puzzle that seems to violate common sense. The planet orbits very close to its star, producing surface temps around 439 degrees Celsius, or 822 degrees Fahrenheit. That's hot enough to melt lead. And yet, it's believed to be covered in a form of ice. That's right, burning ice. Ice that stays frozen solid despite being hotter than an oven. How is this possible? The answer: immense pressure on Gliese 436b. The planet's powerful gravity is so strong that it crushes the water molecules together with incredible force. That pressure prevents the water from boiling and turning into steam, no matter how hot it gets. Instead, the water is forced into a solid state, a bizarre high-pressure phase of ice known as Ice X or other exotic forms. It's a state of matter that doesn't exist naturally on Earth. It's ice, but not as we know it. It's ice that is held together not by cold, but by crushing, overwhelming force. Sideways glass rain, planet of diamond, world being eaten, planet darker than coal, sphere of burning ice. Each of these bizarre worlds is a clue in the grand mystery of the cosmos. They challenge us, they inspire us, and they remind us how much we still have to learn. So, which do you think is the strangest? The beauty of it is, there's no right answer. The real prize is the journey itself, the endless quest for knowledge among the stars. The universe is waiting,